I absolutely love how that fits, but we have just made our first critical error on this project. Welcome back to Centerline Designs, everyone. My name's Cole, and we are on part 2 of making these hubs and getting our sprockets mounted to our all aluminum Snowcat. So in part 1, we went ahead and we cast our very own polyurethane drive sprocket. This is a final use part. It was designed by myself in CAD. I didn't copy anything. It's completely designed by myself, and we made a final use part. We used 3D printed molds that we did ourselves as well. I really like trying to do as much as I can in-house. I really just love the challenge of it. We also went ahead and started making the faceplate that this mounts up to. That'll be on the vehicle itself. And that's where we're going to pick up today. We need to go ahead and get this sleeve welded onto the faceplate that will sleeve onto the wheel motors. Then we need to go and machine everything to final dimensions, because right now everything is oversized or undersized if you're referring to an ID. Because it's always better to do all the welding, let the heat warp, twist, do all of its work, and then we'll go machine at the end. I'm thinking about this one. So if you haven't seen part 1, I highly suggest you watch it. This was a massive milestone, and I'm really proud of the progress we're having. There's a lot more work to come. So in today's video, we're gonna be welding, machining, test fitting, cutting a keyway with the lathe. I think it's gonna be a pretty cool video. So let's go get to work. If you're new to my channel or the build, this is our all aluminum Snowcat. It's powered by a 1.9 liter Volkswagen turbo diesel. It's hydrostatic drive. And again, like basically every other aspect of this vehicle, I've taken inspiration from things that exist, but nothing else exists quite like this. It's also amphibious, which I haven't discussed much yet because we'll show that later on. But it's come a really long ways. We finished track building through the fall and early winter. That was a pile of work. We sent them away, get galvanized. Tracks are looking really awesome, and we're very close to driving, but we'll see when that actually happens. All right, well, with that being said, let's get back over to the lathe. We have that faceplate chucked up, and we need to start doing machining, and then we'll go and do some welding. $23.16. Oh, this took so long to get set up. Oh well, we can do it again. This is exactly when a nice rotary welding table would come in handy. I wouldn't have to try and manipulate myself. And I'm not real great at welding round things. I usually doing, more straight line welding. So I am by no means an expert at welding circular objects, but this is 5/16 plate, and you can see that heat affected zone, and it welded in pretty nicely. I mean, it's still radiating a lot of heat. We did 3 passes. I'm pretty happy with that. I think it's gonna be more than adequate. So we're gonna let this cool down a little bit, and then I gotta go chuck it back up in the lathe, and that took some time. And then we'll see how true we are, and we'll do a little final machining on this and hope for the best. I think we got that pretty close. That's low. That's back to within the 20, 30 thou. I mean, it's a plasma cut edge. There's nothing saying that that is true round, so you could chase your tail all day. We got it pretty close. We left enough meat on everything that we really just need to get close, and we machined to final size. So let's go ahead and start boring out and shaping the sleeve that will go on the wheel motor. That sleeve twisting is to be expected. It's gonna happen anytime you weld something like that. And if you leave enough material, when you go to machine to final size, you kind of shape that cylinder dead true out of all the extra material. So even if it twists off, that's okay. You're gonna make a cylinder out of that runout. And on the inside of this, I maybe should have left a little bit more material. It's gonna be close here, but let's see what we do. Well, there we go. We're gonna let this cool down because it is pretty hot and I wanna get a fairly accurate final result. So I'm gonna let that cool down a little bit. We can go ahead and start working on this. We'll come back to the ID, and then I think I'm gonna take one of the wheel motors off just to test fit it. I am famous for overshooting measurements and stuff like that. I'm not really much of a machinist. I need more practice, but I'm trying to be careful on this one because I really don't want to redo this. All right, well, let's rejig. Let's see. It shouldn't fit. Okay, good. It doesn't fit. Okay. Alrighty. Oh, that's good. It just shouldn't have been fitting yet. This should be pretty nice. Yeah. Okay. Woohoo! I didn't overshoot my measurement. Took my time though, so I got her. All right, well, let's chamfer off these edges here. I'm gonna clean some of this up. Clean up this face a little bit while I have it this way. And then before we take this out of here, I need to do the cross drill and cut that keyway. So this sleeve is perfectly true right now, and we will be machining everything to the trueness of this. So without disturbing it, we're gonna go ahead, cut that keyway. I need to cross drill a hole for a relief for the cutting to go into. And then we'll make sure we have all the machining done on this side. We'll flip it, we'll grab this in the chuck, make sure that's true, and then we can machine the side the sprocket goes on. You really gotta think about how you're doing these things, because to reset this up with the setup I'm doing is not be easy to get this true. So yeah, I'm trying to be smart, but I really don't know what I'm doing. So forgive me if this doesn't work. I've taken a piece of high-speed steel, ground it to the width of our keyway, and very sketchy holding it in our tool holder. And the idea is we just take the carriage in and out, just a couple of thou at a time, and just shave off metal until we have it to depth. This is going to take a little while, so I'm going to see how it goes, and I'll bring you back in if it's working. And that's about it. That's about how complicated this is. It's a very brute force method of doing it, but I didn't have a broach, and they are very expensive. So I've heard this can be done, never tried it. Let's see how it goes. Yay, we did it! Cut a keyway on a lathe. That is a first for me. And it worked pretty good. I got a little bit to clean out at the back of the hole, which I knew would happen. I drilled that through hole to be able to have a place to end, but the HSS wasn't quite long enough, so I need to cold chisel or file that end a little bit. Little die grinder. But majority of the keyway's nice and good and will engage properly, so. Oh, that was such a relief. Never done it before, and I hope you appreciate that. Took several hours of setup, trial, error. I mean, you probably only seen a couple of minutes. That was a lot of work. That was not easy, but I'm happy to be able to say I can do it. Yeah, so I'm just gonna clean that up with the die grinder, get rid of the end in there, and then we're gonna chuck this up in the lathe and grab onto this the sleeve, and then true up where the sprocket is gonna sit to that, so that we don't wind up with a wobbly sprocket either way. And then we can test fit it on the rig. So yeah! Oh, I'm so happy that worked. I did not want to have to do that again. Yes. Oh, that's a milestone, I'm telling you, in my head anyways. Okay, well, let's go put the jaws back on the chuck, hold it by this, and finish truing up everything and get this sprocket fit up. High, take down. It's a little low. Okay, we got that within about 1/1000th, 2/1000ths of an inch, which is plenty for what we're doing here. Let's go ahead and get some things to dimension and hopefully not overshoot the dimension. Okay, well, GoPro batteries were just dying on me. I went ahead and finished all the machining. I almost think it might be time for a bigger lathe. Probably not. It should be close. Now, I would really love to have had a set of calipers that could measure all of my dimensions and not just sort of use guesswork. But larger calipers are very expensive. And it's not every day I need to do this, but here we are. Is it gonna fit? I'm just kidding, that's about as much drama as you'll see on here. Of course it's gonna fit, I'm gonna show you. All right. It's a beautiful fit too. There we go, let's put it on this way. Ready? Yeah! Oh, I'm gonna stop for the day here because this is a massive win and I can probably only screw it up from now on. So I'm gonna call this good, and in another day when you're gonna finish this up, get the ring on here that'll bolt through and sandwich the sprocket. I'm really relying on that being the main way to transfer all the forces. So yeah, we'll come back at this another day and finish off this video, but like, I can actually pick up the hub, you know, my fingers aren't touching it and it stays in there. That's a nice fit. Okay, so to that critical error. I'll fill you in on the little backstory here. So it was either later that night or the next day. I'm thinking to myself, you know what? I really should fit this on the machine and see how this all works. So I fit it up, wrapped the track around, and it just became very obvious. And I want to share this with you. It wasn't necessarily just a complete oversight on my mind. This critical error came from a change and not assessing what that change affects. So as you can see, like, this is exactly how I wanted this to look. I mean, it lines up, it's center of the tire, the track wraps around really well. For all intents and purposes, this is exactly how I imagined it. So what happened? Well, what happened was when I did my design on this vehicle originally, if you've been around from the beginning, I was planning on using a drive tire, a singular drive tire. And I know that sounds a little ridiculous. I think it could have worked, but ultimately would not handle the torque I was going to be putting through this. And I was thinking of going with a tire to get myself going on the project because I was really having a problem trying to think about what I was going to use for a sprocket material. I didn't know what was out there. I couldn't find anything readily available. I was originally thinking of going with a CNC cut UHMW sprocket. But as I got talking with a plastic supplier, they really felt UHMW, although it's a really good wear-resistant material, was not what you wanted for this purpose. They suggested nylon. Well, if you get looking at the price of nylon, it's expensive and was just not in my budget. So, as I think I've mentioned, a person in the comments told me, hey, contact Specialty Resin. They have this 65D tough cast material. They use it to recoat Snowcat sprockets with success. And I got looking into the product. I was really happy with it. It wasn't all that expensive, so I went with it. And that was really the point in my project where I decided to go, okay, we're not gonna use a drive tire. We're gonna go with a sprocket. I now know the material I can make it out of. I knew I could design it and print my own molds, pour my sprocket, and I was really looking forward to this. And I absolutely love how it turned out. The problem is that change. And what the change was is in all my designing of the grousers, the way the wheel motors mount, my adjustments, everything like that was based around about a 22-inch, 23-inch diameter tire to give myself the diameter to clear everything. So you might be seeing where I'm going with this. I then go, let's go with a sprocket. And originally I'm thinking in my head, let's go 19 tooth. I think that lands me around 20 inches. But then as I started second guessing all my hydraulics calculations and torque and drawbar force of the vehicle and everything like that, because don't kid yourself, there's a lot of background design went into this that I've never really been able to articulate to you because it just doesn't make for good content. But I spent probably a year designing this rig in the background before we started it. So it was that change. I decided to go with a 19.2 sprocket. I second guessed that. I went, you know what? I want power over speed. I want torque. This needs to be useful. I need to be able to push some snow with it, go up hills. I'd like it to go to a certain speed, but I would accept a lower speed and higher torque. So that means we need to go down on sprocket size. And this needs to be a odd number 2 sprocket because of the way it engages with the grousers. A grouser only sits on every second tooth. And by having an odd number tooth, that means every rotation, grousers see a different valley in the sprocket. So this sprocket will wear half as fast as you think it will, because there isn't a grouser in every groove. And it cycles every revolution, much like a bulldozer. So let's go down to a 17.2 sprocket. I want some power. Not realizing by shrinking that diameter over time, I was introducing a problem that I just did not foresee. And that is these grousers are hitting the wheel motor mounts. Let me wrap up the track on here and I'll show you what I mean. All right, so there it is. That looks pretty awesome, I must say. I know it's a weird thing to be excited about, but to have designed your own sprocket that engages with your track, like all this is designed by myself. And it looks really good. As you can see here, see how there's an open groove in between every 2 grousers? The next rotation, this grouser, will be in this groove or something like that along those lines. Now this might be a little hard to see, but there you are. These are gonna hit this wheel motor. There is no clearance on that. And that is really disappointing. So that's a little bit of a difficult thing to show, but those grouser wheel guides are hitting the wheel motor bracket, and I was quite positive that, I checked all that in my designs, and that wasn't gonna happen had I gone with the drive tire. So I can't stress enough, if you're doing a custom project and you make a change, really gotta make sure you fully assess what that affects. And that was my critical error. I failed to assess by shrinking my diameter what it was gonna change. So I guess the question is, what are we gonna have to do about it? Well, first off, we're obviously gonna have to go backwards, which sucks because in this project, I really have not had to go backwards very much. Maybe like I welded on a bracket wrong and I had to grind it off and put it back on. This is gonna be the furthest backwards I've had to go in this project in 2 years. I really like this sprocket and that hub turned out fantastic. So I'm gonna try my hardest to keep that stuff. This wheel motor is offset down from its mount by about 3 or 4 inches, something like that. And the tensioning, the coarse tensioning on the track is done by some jack bolts that pull the wheel motor back, and fine tuning is done with tire pressures. So I think we're at this a couple weeks after I noticed this because I was frustrated. Try not to get worked up and I try not to make rash decisions because when you're frustrated, your mind is not working well. So my heart sank. I mean, when I noticed that issue, my heart fell and it made me quite upset. Might not have been obvious, but I was. And I actually lost sleep over this. But after giving it some time, thinking about it, mulling it over, at first I thought, like, we're cutting into the back end of this vehicle and I'm gonna have to redo things. I didn't know what that's gonna look like, but to me, I thought it was gonna have to be very significant. And I still think it is gonna have to be significant. The first thing I wanna try mocking up out of some like 1/8 steel, I won't build it out of heavy plate yet, is I want to try bringing that wheel motor up. Now, it's where it is because the center line of the wheel motor The shaft center is in line with the tires because I didn't want that sprocket up higher and create a droop slack in the top of the track. I really wanted everything center along the axle line. I'm gonna try moving that wheel motor up and shrinking the mount around the wheel motor so that nothing protrudes around the wheel motor casting. And I wanna see where that gets us. I think that will solve this issue. That is like the ideal solution, because then all I have to do is remake 2 wheel motor mounts, which isn't that difficult. However, I now have to design a new tensioning method. I gotta figure something else out, because now the wheel motor is gonna be in the way of those jack bolts. Not too hard, I got some ideas. If that doesn't work, I think we're gonna be cutting into the back of this, moving the wheel motors a lot further away, extending that sleeve that we put on the hub, and then probably have to have a pillow block bearing to support that. So we'll wind up having, you know, maybe a 12 to 16 inch shaft off the motor to the sprocket with another support. And that's just a lot more stuff that I don't want to do. But obviously I'm gonna have to. I'm far enough into this project, there's just no stopping at this point. Yeah, it kind of sucks. This all sort of comes at a time where I kind of have to hit the pause button on this project. If you've been following my channel, we have a upcoming house lift. We're taking our 1,200 square foot house, lifting it about 4 feet, putting in a basement, digging it out, foundation, walls, and we're doing it all ourselves, and I plan on having a build series on that. So we've already have some loader videos that I've been working on getting up to snuff for this summer, because that's a critical part in this house lift. And then we have some very large 16-inch I-beams that we need to laminate up and build a double 16-inch I-beam, 42 feet long, and we need to do that twice. So there's a lot more aspects I need to change my focus to for this upcoming house lift. So I don't know how much further I'm going to be going on this project at the moment. We're obviously not stopping. This is going to continue, and I do kind of suspect if we have some rainy days through the summer, I'll be itching to get in here and puttering with this. So I'm not gonna say it's gonna completely stop, but progress on the Cat is gonna have to slow down, because the one promise I made my wife when I decided to build something like this was that this was not gonna interfere with our house. Pretty good promise. That was my only condition. So I'm gonna have to respect that. I really wanna get this house project done. I think everyone's gonna enjoy it. It should be pretty good for the channel. I'm pretty excited, very nervous, but I love doing things I haven't done before. So, although I have lifted a house before. So anyways, very open on this channel. I share my wins, I share my fails. This wasn't just negligence. I did have a design. I had it all thought out. What I wanna articulate is that when you make a change, that's usually where you get stuck, and it stuck me. So anyways, I'm gonna leave this here. I hope you enjoyed all of this. It was really cool. This sprocket, I think, is gonna be awesome once we get the drive sorted out. It is what it is, right? Don't dwell on the negative too much, stay positive. We're just gonna have more content creating some new wheel motor mounts. So every fault sort of has a silver lining in it when you're doing YouTube videos. Stick with me, and we should do some fun things. So we'll see you in the next one. Cheers.